Okay, let's go ahead and get started. So what I want to talk today about is web components. It's a new standard for some of the browsers, and hopefully will be the new standard for all of the browsers within the next year or so. So let's dive into it a little bit. So what are web components? So web components are a collection of standards that help bundle up your styles and your custom HTML elements. It makes it where you can fully encapsulate hiding your HTML from external JavaScript and your HTML is safe. What that means is that with web components, you're able to produce custom elements that are actually hidden away from the rest of the markup page. And so you can create a element that inside of it has HTML markup that a JavaScript scraper cannot actually go into and change and make find and do things on the elements and stuff like that. And so it makes it where you can completely encapsulate your HTML and keep it hidden away from any external applications. And these are the four main components that make up a web component. There's templates, there's custom elements, shadow DOM, and HTML imports. All of them are now fully supported by Chrome. There was just an announcement last night that with Chrome 36 that they now have full support for all four of these. Opera has support for almost everything except for the custom elements. Firefox has support for most all of this also. IE right now doesn't have any support. But like with IE, with everything else, there is polyfills that will actually allow you to use all four of these elements. So let's talk, and all four of those elements with IE that actually are on the roadmap. So they should be coming natively with IE pretty soon, I'm hoping. So let's talk about each one of these individuals before we go into some examples. So the first thing is templates. Templates is actually supported by all the browsers now. What a template is it is a element that has markup inside of it that can be used at a later date. None of the sources or links will actually be downloaded. So what that does is it gives you the ability to create a small template area, and like in this example, you have an image inside of it. That image isn't downloaded until you actually render it onto the page. And so it gives you the ability to do some kind of neat things where you can actually load the page, and then if you have a bunch of images on it, you can instantiate each one of these, and your images won't be downloaded until you instantiate that template. And so you can get some performance around that if you have a lot of images on your page, because you're not trying to download all the images at one time. Someone needs to go on mute, please. So the next one is custom elements. Custom elements are a new type of DOM element that can be defined by the author. The custom element can encapsulate state and provide script interfaces. So you can see here we have a element that extends a button, and you gave it a name of fancy button. Then inside of it, you can actually have scripts tags in there that allows you to do things on that element. This is very similar to Angular and the directives, where you define a element and then you'll have scripts that attach itself to that element so you can actually do stuff with it. In this example, you have a tick function. If you were doing this in Angular, that would be a scope.tick. And so you can actually do things on the elements. The next one is the Shadow DOM, and this is probably one of the big pieces of web components, and why I think it's pretty important coming down the pipe. The Shadow DOM is a elegant way to overlay a DOM subtree with a special document fragment that contains another subtree of nodes which are impregnable to scripts and styles. Shadow DOM is actually in all the browsers today. This is how browsers handle video and audio on the page. So when you see a video tag and audio tag, what happens inside the browser is they actually have a Shadow DOM in there. The problem is currently with the older browsers is that Shadow DOM is hidden away from everyone and you can't use it. What the specification is basically doing is allowing everyone to use Shadow DOM for any kind of element or custom elements that you want to create. The nice thing about this is that the Shadow DOM, like this example, creates a shadow boundary around that shadow tree. And so you can't go into the shadow tree and actually affect anything inside of it. This is mainly like with styles. And so if I have inside my shadow tree a button element, say, and I style that button element to be a background of red, if I go into the main document, into my main CCS, and I say all buttons are green, the button inside the shadow tree will still remain red because it is impregnable to any style outside of it. It will always use this internal style. This is very similar to using the important on a style, but now you don't have to use that, and you can actually keep your styles to themselves. But this also goes with scripts, and so if you create a element inside of your Shadow DOM, you can actually hide it away from HTML or JavaScripts going in and actually affecting your elements in a way that you weren't expecting it to be affected. So I think Shadow DOM is one of the more important things, and the examples will show you why. And the last part is HTML import. What HTML import is the link, and basically being able to import a full HTML page from an external link. It goes beyond just markup though, is you can also import the CSS and JavaScript with it at the exact same time. So what this does for you is envision like Bootstrap today. When you look at Bootstrap, what we have to do is we import all the CSS in one file, we import all the JavaScript in another file, and if we have any HTML, we'll have to import that a third way, or actually embed it into our page first, then use it throughout the rest of the application. With the HTML import, we can add all that together into one document and import that all at one time. And so here's an example with the bootstrap.html. Inside of this bootstrap would be all of the markup that we would need, all the CSS and all the JavaScript. We would not have to do individual files for the markup and the styles. And why should we care? One is this is the future of web development. I think as the web components actually mature over time, you're going to find more and more shops using web components to give you as a third party. And then internally, I think you'll start writing web components for very common elements that you want to share throughout the company, and have it not affected by the application that you're actually trying to write. And I'll show a couple of examples like that. Angular 2.0 is working to integrate these parts. I'm going to show you a page called nglearn.org, which is going over the 2.0 specification. But basically templating, they're looking at integrating the Shadow DOM elements part of it, and also the templates tag. And so one of the things I think you're going to find going forward is with directives, you'll probably actually write that as a template, and then they'll have the ability to inject the shadow DOM into that template on compile time. Also, some of the routing, I think they're going to try to do some stuff around that with some of the templates. You actually may import a template or import a HTML that will actually handle some of your routing for you. So, you know, I know Angular team is working very hard trying to get some of the new web components specification together. And then Google, in general, is using Polymer for its new material look and feel. And I'll show a couple of examples of that. On top of that, between the Angular and Polymer teams, they're actually working together trying to come together on custom elements. So today, you can write custom elements in Polymer, or you can use directives. What Polymer is a way of taking the web components and pull them all together into one common API, so that you can create them a lot easier, and you can actually give a element tag rather than, like I'm going to show you in the examples, where you have to kind of make this large code base to have it work inside your page. You can actually just give a tag, you import the Polymer HTML and use that. The thing is it's not part of any framework, and so that's one of the differences between Angular and Polymer is directives actually work within the confines of the Angular framework. And so you have situations where you're communicating from your elements out to outside scopes, and to controllers, and to services, and so you have to be able to inject that kind of stuff. And then you want to be able to fire off the digest loop because of that. But the cool thing is, though, is that Angular and Polymer are working together, and some of the libraries they're actually going to share so that they can able to, if you write Angular 2.0 directive, behind the scenes, it in Polymer will write the element the same way. And so being able to blur these two things together in the future is what's going to happen. The other thing is that if you have a Polymer element in the page, Angular will view that and see it as just another DOM element. And if it's not in its directive queue, then it won't try to compile it. It will just see it as just another element, and it will skip over it. So let's look at some examples real quick. Now, any questions on what we looked at so far? Great. Okay. So let's look at examples. So this is the very first example I have. This is a simple button that is you're being rewriting the text for. So let's look at the actual page here. So this is a very simple version of the web component. And so you see here I have a button. It originally said hello world. And then I have a script here, and what I'm doing is I'm grabbing the button, I'm adding a shadow root to it, and then I'm rewriting the top of the button. So if we actually open up the console here, we inspect the element, you can see now we have a shadow root here. And the shadow root name is changed compared to what the original one was. So this is the original hello world, but the shadow root actually has this Chinese characters for the name. So one of the nice things is in the Chrome browser you can actually turn on shadow root. So if I come over here to this cog, I can turn this on, and it will show the shadow root for me. And I actually have it turned on other places, and that's why that didn't come up. So that's one the very, very simple example of a shadow DOM. This is a little bit bigger example. So we're making a tag here. So let's look at that code. So we open up this. So what I have here is I just have a HTML tag with name of Bob, and that's all I have. And I created a template here. So here's my template. Now my template actually has a different HTML in it. It has a outer div. We have a class called boilerplate. Hi, my name is a div class of with Bob in it with the class of name. I have some styling that I want to do on my template here. So this is how we do the red, we do the borders, we do the radius and stuff. And so how this works is I go and grab my name tag. So this is this guy here. The next thing I do is I create a shadow root for it. This actually will change the new specification. Instead of being WebKit, it just creates shadow root. But for the time being in Chrome, in Safari, it is WebKit create shadow root. And I think with version 37 of Chrome, they're actually taking the WebKit piece off. So I go and create a shadow root, and then I also go and grab my template that I have. So here's my template, and I'm appending my the template into my shadow root, and then I remove the template completely from the page. And so when we look at the HTML of this, you can see here's my name tag, and then I have my shadow root here, and here's my style for my shadow root, and here's my template for my shadow root. And all this is actually hidden away from any external piece. So if I go in and I try to find a class of name, find element by class, I will not find name when I do that search, because it's inside the shadow root. And then they have my scripts here. And you can see also, since I removed the template, that guy is no longer in the page. Now the template never renders, and so there's no reason to necessarily delete it. I just like doing it because it makes it easier when you look at these demos of what you're doing. And so you can do an even cool thing. So here's an example where I've created a custom element that has a transition on it. And so if we look at that example, this is a little bit more entailed because we have all these styles here, but it's basically the same thing as what we had in the previous example, but these transitions will only, if I do a transition on something very common, it will only work on the things inside my shadow DOM. It will not work on stuff on the outside. So I want to give a little bit more of a real-world example. So here's a I'm a button. And if we look at the element here, we can see I did the same thing that I normally did. Now the difference is that on this particular guy, I actually decided to create this as a directive. So if we look at our code here, this is an actual directive called TL button. And so what I have here at the top is the template that I created for that button. And basically all that is a bunch of styling. And that styling is actually the Bento styling. So if you go out to Bento and you look at how they style buttons, that is all of the styling for a button. And what I have here is the actual button itself. Inside my code here, in my linking function, I create a shadow root element for this, and then I basically compile this template, and then the next thing I do is I replace this piece with whatever is in my transclude, and then I append this into my page. And so we look at demo 4. You can see it just says TL button, I'm a button. and here's my button. So if the Bento team wanted to say, here's some buttons, and we use web components to isolate it, they can do that. So now if we look at, if I uncomment this line, this is another directive I created called HP, and you can see that these buttons are just different styles. And if we look at the HTML of it, you can see here it has its shadow DOM, and here's a styling that is slightly different than the styling for us. Now you notice on my styling though is I've used button. So what I'm trying to style is any button. So if we create just a normal button, like we would any other way, you can see I have three different styles of buttons. So here's where the magic comes in with web components. Is if I go into my CCS here, and I decide I want all my buttons to be red. So here you can see I said every button that you see, any element tag of button, make the background color red. And I save this, let it compile. You can see my button is actually red now, but it did not affect either one of these directives because those stylings are inside the shadow DOM, and I cannot touch the shadow DOM from outside. I can only affect it on the inside. So what this does for us, or what it can do for us, is for components that need to be the same no matter where they're at, it will eliminate a lot of the styling that we are doing and all the hoops we have to jump through with all the different styles that we have. We can just have this button, and we know if we need to make a button red and it happens to have the same class or the same name as what our web component button is, we won't affect it if we make changes into the styling of that elements or elements that we have. So I think that's where the magic lies in the web components. Here's the ng-learn. This is some of the Angular 2.0 status and previews, and one of the things you can see here is about templating. And this is where they talk a little bit about shadow DOMs and what they are trying to do. If you are a member, if you go out to Angular teams actually will publish the meeting notes from the weekly meetings, and you'll find in there them talking about how to use Polymer, what library classes they want to use, how they are looking at doing some of this stuff. And so I would recommend going out and doing some research on what's coming down the pipeline for the Angular team, so you can kind of see what their thought process is on stuff. So this is a Polymer page, the Polymer project, but this is the paper elements. So all these components are available to everyone. And this is Google's basically standard now for web development. And so you can see when you click on a button, there's certain transitions and stylings going on all the new elements that they've created. It's called paper elements. Probably the neat one is shadow. So they're getting really big on, because of the way cell phones work, it's trying to style stuff. So you can see I can lift this up and then drop it back down, and you can actually kind of see that elements. But all of these are Polymer elements. And Google is recommending, if you're creating anything that is Google driven or the Google internal teams, they're going to use these Polymer elements throughout the application. And it gives them a very a way of people having styles that fit the Google style guide without having to import large style sheets and then having conflicts because there's certain pieces that need to look just slightly different. And that's one of the reasons why they're using Polymer and the web components, is so that it doesn't necessarily affect everything else in the page. This particular page here, the webcomponents.org, this is a web page for the community where they're trying to keep people up to date on where web components are now. The browser support here is showing you for each one of these components how everyone is doing on implementing this. Like I said, but all of these have a polyfill, and so you can actually use polyfill to use it. And then the other place is Component Kitchen, which is kind of neat. These are all web components that people have created that you can actually go out and use. One of the cool ones I've seen is there's actually a Twitter one that's kind of neat, which you can use it and then it will do tweets and stuff for you. Polymer actually has a couple other examples using the new piece. A little bit about Polymer. So what all Polymer is a way of writing these web components in a more succinct way and compiling them down into smaller pieces. So there's really no magic there. It's just they created this Polymer element that defines the element, and then inside of it is the standard templates and stuff like that. And what will happen is Polymer will basically do the same thing like what Angular does. It will go through documents looking for these Polymer elements and then creating a custom element for you. But everything inside of here is basically just regular web components. The only real difference is this Polymer object. And what the Polymer object does is it allows you to pass attributes into the element, and they're doing some two-way binding that way. So like I said, I wanted to do a real quick intro to this. There's a lot more that you can kind of dive into and see, but it is something I think that is important to look at, because a lot of the teams in Google, in Apple, in Microsoft are looking at these web components, trying to make it more of a standard. And I do predict within 2 years, all of them will have these components in their browsers, and people will start using them a lot more. And so you'll find when you go out and look for third-party stuff, you're going to find a lot more web components out there than you will just standard JavaScript libraries. You'll find actual just web component libraries for you. Any questions? Okay, well, no questions. I guess that's about it. That was a short one. So if you have any questions that you forgot about, just email me. If there's anything you guys want to talk about in the future, just email me, and we'll get going with it. Thank you, guys.
Wait a second.
Well,
can you, some of these links that you were just showing, can you like send an email around with those links?
Yeah, I plan on doing that on the hub piece.
All right, sounds good. Thanks.
All right.